Hey, I'm Jared Pierce with Gulf Coast Supply Manufacturing. I'm the Technical Services Manager. Today we're going to go through conversion charts and getting wind speed to pressure to determine what kind of panel you can use on your roof and the fastening pattern that you need to use for that panel. So we have this new cool tool on our website. It's the setback finder to determine warranties and whether or not you need an aluminum panel or you can get away with steel. You can see over here is the legend, kind of the zone. The red means you can't be within 1,500 feet of salt or brackish water. The green is large bays and canals, and then the blue is large bays and canals, and then the green is the marsh area. So obviously right here we're within 1,500 feet of the Gulf. You can see that by the red circle. So we know we're gonna need the aluminum panel right off the bat. I can determine too, this will make more sense in a minute, I'll go over this, but I am also exposure D because I'm within 600 feet of an open body of water. So keep that exposure D information in mind. So 3 pieces of information I'm gonna need exposure, I'm going to need building height, and I'm going to need wind speed. So if we go to our ASCE hazards tool, you can just put this in on Google, ASCE hazards, it'll pop up. It's the very first one. You can use this for any building code, IBC, Florida building code, Miami-Dade NOAs, wherever you're at, this tool applies. I can put in any address and it will pull up the wind speed no matter where it is. So I put in the address. This is a risk category 2 structure. I can see the structure here. It's a hotel. It may hold more than 300 people. The delineators between that, risk category 1 is any structure that doesn't house people. Risk category 1 structures are barns or anything that's not occupied. Risk category 2 is the next step. It's most residences or anything that will hold, anything that will house 300 people or less. Risk category 3 structures are anything that hold 300 people or more, so a condo, that will house more than 300 people, a hospital that doesn't have an emergency room, any large structure, a school that doesn't act as a shelter when a storm comes through will also be risk category 3. And then risk category 4 structures are anything that has to stay open in an emergency. So any critical structure, a fire station, EMS, a hospital with an emergency room, or a school that is a storm shelter will be a risk category 4. So again, risk category 1 is unoccupied. Risk category 2 is almost everything that a roofer will deal with. Risk category 3 is anything non-critical that will hold 300 people or more, and the risk category 4 is any structure that has to stay open during a crisis. So for this one, I think it's either risk category 2 or risk category 3. Looking by that, I'd say that probably, it could hold more than 300 people. So we will consider that a risk category 3 structure. All that's gonna do is it's gonna adjust my wind speed up slightly. So risk category 3, I need wind. I'm gonna view my results. It's gonna bump me up to 154 miles an hour. If you want the full report to add, you can print out the full report, but really all we're looking for here is the wind speed. And my end goal, I'm trying to convert this wind speed into a pressure so I know what panels that I can use and I know what my fastening pattern has to be on those pressures. Again, it'll make more sense in a minute. Once I have my wind speed, I'm going to go to the Florida product approval. I know this structure is really tall, so right off the bat, I'm gonna have to have a panel that meets a really high pressure. On our website, you have a Miami-Dade NOA for most panels. Your non-HVAC is gonna be all inclusive, so everything that is in your Miami-Dade NOA and everything that is in your HVAC approval will also be in your non-HVAC approval. So the non-HVAC is the biggest one. I'm gonna use Versalock. It's our mechanically seamed panel. I know we're gonna have a really high pressure. Let's go to non-HVAC. So you'll start reading these approvals from bottom to top. There will be conversion charts on the bottom. Here you can see exposure B. We said we have an exposure D structure because we're right on the beach. The next one is exposure C. And the next one is exposure D. So we had 154, 156 mile an hour winds. I don't have anything in between, so I have to bump that up to 160. My roof height, I know, is really tall. If I zoom in, I can see, right there. If I zoom in, I can see this bottom floor. Every floor is approximately 10 feet. Most stories are between 10 and 14 feet tall. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then the peaks up top, I think it's 104 feet. We measured it, it's 104 feet to that top peak there. So roof height is really tall. I'm right on the beach, I'm exposure D. This is worst case scenario. I know my pressure is gonna be really high. Can we still put metal panels on it? Absolutely. Go back to my chart. Because I was at 160, I'm gonna bump up just to give you guys an estimate on the pressures. But our mean roof height only goes up to 60 feet. So we know we'll have to do engineering. This chart is this is allowable design pressures for gable and hip roofs, exposure D, which is what we want, and then roof slopes between 212 and 1212. So if it's outside this range, we have to do engineering, and if it's outside this height limit, we have to do engineering. So in this case, we're outside of the height range. But for the video, I'm going to show you, what I'm gonna do is I'm gonna bump up to the next highest wind speed, and then I'm gonna go with the highest wind pressure just to kind of show you what pressures we need. So we were at 164, we'll bump up to 170, 60-foot roof height. You need 3 pressures. You need a zone 1 pressure, a zone 2 pressure, and a zone 3 pressure. I'll go over that more in a minute. So I need 186.8. I need 142.4, and then I need 107.8. And those are zone 1, zone 2, and zone 3 pressures. This is just a picture. On this side you have a hip roof, this side you have a gable roof. One advantage to a hip roof, just a fun fact, you do not have a zone 3 at the ridge on a hip roof. Zone 3 you do have on a gable roof at the ridge and at the eave. So these zones are broken up. Zone 1 is typically your biggest zone. Then you have zone 2, which is all your perimeters, whether you're on the ridge, gable end, or the eave. And then zone 3 is wherever you have 2 zone 2s coming together. So again, on a gable roof, you have 2. You have one at the eave and one at the ridge. On a hip roof, you only have one at the eave. So to determine how big these zones are, you're given this A measurement. So A measurement is 10% of your least horizontal measurement, or 3 feet. Your A measurement is never less than 3 feet. So if you have a roof that's 20 by 100, typically your A measurement would be 10% of that 20. So 2 feet, but your A measurement can never be less than 3 feet. So I'll give you another example. If I had a 60 by 70 building, so my building is 60 feet wide, 70 feet long, my A measurement is gonna be 10% of the least of those 2 measurements. So if I have a 60 by 70 building, my A measurement would be 6 feet. 10% of that 60 is 6. All that does is that tells you how big your zones are. So how how wide your zone 2 is, how wide your zone 3 is, and then zone 1 is whatever is left over. So on this building, my building was 119 by 70. My A measurement is gonna be 7 feet. So my zone 3 is gonna be 7 feet by 7 feet. Zone 2 is gonna be 7 feet wide, the length of the building, and so on. So my A measurement for zone 1, the pressure that I need in that zone 1 is 107.8. The pressure that I need in zone 2 is 142.4. And then my zone 3 pressure, which would be my highest, is 186.8. Once I have those pressures, I know where they are on the roof. I'm gonna go back up on my product approval, and I'm gonna see if I have a panel that will meet those high pressures. So if you need to know what all these are, each will tell you clip spacing, 3-inch base, 8-inch on center, 2 fasteners. There's some in here, 90-degree seam. There'll be some that'll tell you with sealant, with continuous bead of sealant in that leg. All these are just different fastener patterns that you have to use to get to the pressure that you need. So here's your pressures over here. This will call out, like VL5 will be VL5, and then it'll also call it out here. But I know for this roof, I need to have an 032 panel, so I need to be aluminum because I'm right close to the coast. Here's my anomaly 032, 032, and then 24 gauge is here and down. So do I have an 032 panel that will meet that 186.8? I do not. I'm at 159.25. So I know right off the bat I'm gonna have to do engineering to get to this pressure. Likely we will shrink this clip spacing down from 8 inches to 6 inches and then use sealant. I could also probably go down to 3 inches if I had to, which means the clips would be touching in that zone 3. I would open them up because I need 142.4 in zone 2. So 142.4, I could get away with 8-inch clip spacing, 24 gauge, you know, this VL2 fastener pattern here. And then in zone 1, I need 107.8. So I could get away with this. I could get away with 16-inch clip spacing and then a continuous bead of sealant in that. So it changes. Likely if we did engineering, we would still use sealant in zones 1 and 2. And then in zone 3, we'd have to get a little creative to get that 186.8 pressure that we need. So when a hurricane comes through, if you want to make sure that your roof is going to stay on, you need to follow these steps. These are the pressures. This would be a very good project. This particular project, we lost out to a competitor that is putting substandard panels on there, and the roof could very likely blow off in the event of a hurricane. It was not designed to withstand the wind speeds that this structure will see in the event of a storm, and we know on Clearwater it's going to see a storm eventually. So just keep in mind these steps. Once you do 1 or 2 of them, they're not very hard to do. The charts are all standard, so the charts that are in the bottom of our product approval are all standard. They're ASCE charts. Those are not something that Gulf Coast created. You can pull those off the ASCE website. You can also pull them off of Florida Building Code. Or you can absolutely go to our website and pull them off the bottom of our charts. But once you run through one of these, they're not very hard to do. You got to keep in mind big picture. All I'm doing is converting a wind speed to a pressure, and then I'm using that pressure to see which panel would meet the pressure and then what my fastener pattern needs to be. So when you get to an area, to make it a little easier, this is what we have all of our sales reps do. When you get to an area and you're only selling in Clearwater, Florida, for example, I know that I'm not in a 120 or 130 mile an hour zone, so I can cross all those off. I also know that I'm not in 180 and 190 mile an hour zone, so I can cross all these off. So the only parts of this chart that I'm looking at are 140, 150, 160, and then exposure may change. So if you're inland, it'll be your exposure B. If you're a little closer to the coast, exposure C, and then obviously right on the coast, I'll use my exposure D chart. So you may have to highlight 3 of these, but the majority of the time you're only dealing with a 20 or 25 foot roof height. I'm only dealing with exposure B the majority of the time. And then when I only sell in a certain area, I'm only dealing with a couple of these wind speeds. So it really narrows down what you have to look at. The chart is all encompassing because we have to sell all over the state of Florida, all over the Southeast. So we have to do a wide range of pressures. But really, when you get used to selling in your area, the chart really shrinks down, and you can highlight for your salespeople. You can highlight a small area, or if you're a building inspector, you know, hey, this is where I'm inspecting. This is the only portion of the chart that I need. You can highlight this, you can cut it out, save it on your desk, tape it to your computer screen. But these are very helpful. And like I said, these charts are not panel specific. So once you know the pressures, those pressures apply to whatever panel. Some companies, if I go and I look at an NOA, for example, a lot of Florida product approvals are only designed like this. They only call out a pressure. They don't have those conversion charts in the back. So when you get a product approval, it will only call out this. You will only have a PSF. So in the field for Miami-Dade, for example, you would have to fasten 16-inch on center, and then in the perimeters and corners, 159 is 8-inch on center. But this does not give you a conversion chart. So I can still use the conversion charts from the other Florida product approval to figure out what my pressures need to be per structure. So that is how to convert wind speed to pressure to determine which panels that you can use on your roof and to determine your fastening pattern for that roof. If you ever have any questions, give us a call. You can look us up online, gulfcoastsupply.com, or shoot us an email, either technical@gulfcoastsupply.com or warranty@gulfcoastsupply.com, and we have a team there available to assist you in your calculations.